All right, parents, this is one of the harder strategies that I've taught the kids. Some of them really understand it, but others are really struggling with why it works. So I'm going to try to teach it right now, and I hope that you can understand so you can support your students if they are struggling with this. Partial quotients is very similar to the algorithm that we were taught as kids. The biggest difference between partial quotients is just that. It breaks it into parts that you already know so that you can use multiplication to help you make sense of the division. The other thing that partial quotients relies on is a basic understanding of multiplying by two numbers. Multiples of 10 or multiples of 100. If you can multiply any number times a 10 or times 100, and or the multiples relating to those tens and hundreds, then you should be able to do this strategy. It looks very similar to the algorithm, but the biggest thing is that it breaks it into parts, facts you already know. And one thing that we explored in class is that there are multiple ways to actually solve each problem depending on which multiplication facts you already know. If you're only comfortable multiplying just 10, then you can multiply it by just tens. It will look a lot longer and it's not quite as efficient than if you're looking for the largest value that you can multiply that number by, but it is still accurate as long as you, well, know the multiplication fact in the first place, but that's beside the point. So I'm going to go ahead and show you two examples. The first one is pretty basic. It starts off with 5 being divided into 125. If you notice, this is our typical division algorithm house. What I've done is I've extended it down into what's called the hangman or the big 7. We just call it the long house for partial quotients. So what the first thing I do in any division problem that I'm using partial quotients as my strategy to solve is the first thing I think about is, well, what is the largest value I can multiply 5 by to get close to 125? I think of 10 or I think of a multiple of 100. Well, I know that 5 times 100 is 500, and that is much too large for this 125. So I'm going to go ahead and think about my multiples of 10. Well, I know 5 times 10 is 50, and 5 times 20 is 100. 100 is awfully close to my 125, so I'm going to go ahead and start there. So since I used my 20 as my multiple of 10 to get close to 125, I write my multiplication multiple, or my other factor, out here, and then I write the product that I got by multiplying 5 times 20 inside the house. Then I subtract to get the value of whatever is left over that I still need to divide. So far I have partitioned out 100 by multiplying 5 times 20, and now I'm left over with 25. Well, 25 is a pretty easy fact for most kids because they know that 5 times 5 equals 25. Those double facts are always nice and easy. But when you see that I divide out or subtract now, I've got a difference of 0. That tells me that here I have no remainder. Okay? I have no remainder there. And I also could tell that I wasn't going to have a remainder because in my ones place back in my dividend, there's a 5. And I know that any time I'm dividing by 5, if my ones place of my dividend is also 5, I'm not going to have a remainder. So how do I find the quotient? Well, parents, we know that we write our quotients up here. But we didn't do any division up there. We did our division over here. So we take the two parts that we partitioned out right here, and we add those two parts up. 20 plus 5 is 25. So my quotient for 125 divided by 5 is 25.